Hello. So in this video, we're going to solve this equation 4/3 tangent theta minus 4 cotangent theta equals 0. All right, so you're definitely going to have to use some identities because you've got two different functions, but you'll recognize that these are reciprocal functions, right? So let's suppose I go ahead and clean this up a little bit. So I want to go ahead and take advantage of the fact that when I multiply tangent times cotangent, because they're reciprocals, I'll get 1. All right, so let's go ahead and clean this up a little. I'm going to multiply both sides of the equation by tangent theta. And so here, of course, it doesn't matter that you're multiplying tangent theta to 0 because it's still going to be 0, right? So now here's the distribution, right? I distribute this tangent theta to both terms, right? So the first term is going to see tangent theta times 4/3 tangent theta. And here we're going to have tangent theta times 4, and let me rewrite this as 1 over tangent theta because that's what cotangent theta is. And here you have 0, right? Anything times 0 is 0. All right, so here you have tangent theta times tangent theta is tangent squared. And then you have the coefficient 4/3 out in front. And now let's pull that coefficient 4 out, and you'll have tangent times 1 over tangent, right, is going to be times 1. So really I have 4/3 tangent squared theta minus 4 equals 0. So let me go ahead and multiply by 3 just to get the denominator cleaned. So here again, you're distributing, the 3's cancel out, you're left with 4 tangent squared theta minus 12 equals 0. Now, or I could have really, well anyway, I like dealing with whole numbers. So really here what we have now, we could factor out the 4, and so we'll have tangent squared theta minus 3 equals 0. And if you recognize this form, it could be that it would be helpful if I said something like let u equal tangent theta, in which case you have 4 times u squared minus 3 equal to 0, and you want to go ahead and factor that. Let's go to the next page. All right, so let me carry that forward and make sure you can see this. Yeah, okay. So we're solving here where we let u equal tangent theta, and we're solving 4 times u squared minus 3 equal to 0. Now remember, technically this is, you know, a times b, right? Have a product equal to 0, and 4 can never be 0, so only the u squared minus 3 can be 0. That's the only thing you really care about. So you could do this a couple different ways. You could say that u squared minus 3, when is that equal to 0? Well, that's when u squared equals positive 3, take the square root, right? So absolute value of u equals square root of 3, and so u equals plus or minus square root of 3. But u was really tangent, so you have tangent u equal to plus or minus square root of 3. Or you could just say, hey, I know I've got the u squared minus 3 is what I'm trying to solve equal to 0, and I'm going to factor it this way. U plus square root of 3, u minus square root of 3 equals 0. So either u plus square root of 3 equals 0, or u minus square root of 3 equals 0. So u equals negative square root of 3, or u equals positive square root of 3. We've got the same place, right? And so that really means tangent, oh, sorry, not u, theta here. Tangent theta equals negative square root of 3, or tangent theta equals square root of 3, right? And by the way, in case you're concerned about this 4, remember, this is really a times b equals 0. So you're saying either 4 equals 0 or u squared minus 3 equals 0. And this is like impossible, so you don't even have to worry about it. That's why I didn't. I just brought this part down. So now you're here answering this question, however you got there, when is tangent of theta equal to plus or minus square root 3? So the idea is, because you see that it's an exact value, square root of 3, right? It's irrational and it's exact. You know you're going to be using the unit circle, and it's got to be one of the angles, special angles that you know that has a square root of 3 as one of the coordinates. So you know it's either going to be a multiple of pi over 6 or pi over 3. But let me help you out. You're really saying, where is y over x equal to plus or minus square root of 3, right? So remember, since when you look at these, you have a square root 3 over 2 and then a half. It must have been that you had square root 3 over 2 and then a half. And then when you flip and multiply, you get square root 3 over 2 times 2 over 1, right? And then the 2's cancel out. And there's your square root 3. But that means the y is the square root 3 over 2 and the x is the half. So you're asking yourself, oh, okay, well, where's that on the unit circle? Where is it that I have this square root 3 over 2 and then a half? And remember, you're looking for both the positive and the negative, so you're really going to need to do both, right? So you're going to have here, and there's no, should I put this? I didn't see an interval, so it's infinite solutions. So it's going to be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, right? Okay. So those are your solutions. If there were an interval, like say 0 to 2 pi, you would just list these 4. But if it's infinite, then you got to list all of them. Now some students will do pi over 3 plus 2 pi, 2 pi over 3 plus 2 pi, 4 pi over 3 plus 2 pi, 5 pi over 3 plus 2 pi. Well, you can do that. What I can see is that 2 pi over 3 and 5 pi over 3 are 180 degrees apart. So I'll really capture all of them if I say 2 pi over 3 plus pi, not 2k pi, but k pi, right? And then I can also see, pen, that pi over 3 and 4 pi over 3 are 180 degrees apart, because again, I can take pi over 3 plus pi, right? Would be pi over 3 plus 3 pi over 3, which gives me my 4 pi over 3. You can do the same thing with the 2 pi, add 3 pi, that's 5 pi. So I'll capture this by saying pi over 3 plus k pi. So that would be your solution, this right here. All right. Thanks so much for listening.